So students, let us just take a quick look on what we have already studied. We saw a coordinate plane, and this is a two-dimensional plane. A two-dimensional plane is a plane, of course, where we have a length and a breadth. Okay, that my that should have been straight. Okay, so such type of planes are two-dimensional planes where you have two dimensions, of course. And for calculations and measurements, we divided the coordinate plane into four parts or into four quadrants, and we divided it by drawing a vertical line and a horizontal line. The vertical line is called y-axis and the horizontal line is called x-axis as a convention. Now, because the horizontal line is called x-axis at the right side, the other side, the other end of the x-axis, we call it x dash. Okay, and because the top end of the y-axis is called y, the other end we call it y dash to represent negative numbers. So at this side, for the horizontal line, right side we put the positive numbers, and the left side we put the negative numbers. For y-axis, the top we put the positive numbers, and the bottom side we put the negative numbers. Now this necessarily need not be integers. You can put any numbers. Now, I mean, it could be a rational number, it could be a fraction, or it could be a decimal. Now, I'm putting natural numbers here, I mean integers here, only for so that you can visualize, only to make things a little more easier, because we are just starting to learn this chapter. Okay, now these divisions, for dividing it into four quadrants, are which it makes the measurements, it expands our view, because since we have negative, we need this are for measurements and for calculations, and it is for such a reason why we have to divide these coordinates into, I mean, this coordinate plane into four different areas or four different parts. Okay, now we saw the equation of a straight line, y is equal to mx plus c. But how it all came about, I just want to give you an insight into how it comes. So let us draw a simple straight line for which we don't need any prior knowledge of equations. Take this point 0, 0. Take next point 1, 1, 2, 2, 3, 3. So what do you see? X is 1, y is 1, x is 2, y is 2, x is 3, y is 3. You see, so that is how the line is going. X is 4, y is 4, x is 5, y is 5. Then the same thing I'll do in the other side. In the third quadrant, x is minus 1, y is minus 1, x is minus 2, y is also minus 2. So do you see that? And x is minus 3, y is equal to minus 3. So you see that x and y are all the same for each point. So I can write the equation of this line as y is equal to x. I can write, right? Because even though I don't know all the line equations of straight lines or curves, even though I don't know that, by just looking at each and every point, because every point fulfills the condition y is equal to x. So therefore the whole line equation will be y is equal to x, right? Now this is the equation for such type of a line, or for such a line like this. But what if I want an equation for all type of straight lines, for every type of straight line? So for that, from this foundation, let us try to build up the equation. Now one thing that I can do is, suppose I want to rotate without changing the position, I just want to rotate the line. Now when I rotate the line, what happens? as I already studied, the slope changes. For example, in this case, this was the slope. When I rotate the line, what happens? When I rotate the line, the slope becomes like this. Do you see that? Now, when I again rotate the line, again the slope changes. The slope becomes like this. Now you see that the slope increases this time. So you see that the slope changes. And or another way to look at it is each time that I rotate the line. Now here y is equal to x. We know that. What happens when I make the line like this? Is y is equal to x anymore? No, because when y is equal to 1, what is the value of x? X is equal to 4. Do you see that? So y is not equal to x. Y is equal to something into x. Do you see that? Again, what happens when y is equal to 2? Okay, this line doesn't go till there, but we can extend it. So when we extend it, we see that x will be 8. X will be 8. So again, so when y is equal to 2, x is equal to 8, or y is equal to 1 by 4 into x. Do you see that? Y is equal to 1 by 4 into x. So y is equal to something of x. That's what happens when the slope changes. And here also you see, when y is equal to, what number shall I take? When y is equal to almost, okay, not exactly 3, but yeah, this y is equal to 3. Now x is almost equal to 1, not exactly 1, but almost equal to 1. And when y is equal to 7, for example, if there was a number 7 here, not if there is a number. So when y is equal to 7, x is almost equal to 2. And so you see, y is equal to something of x. So therefore, let me write it. I will write it as y is equal to m into x. Now m could be any number. M could be any number. It could be a fraction, or it could be a integer. Now the point that I want to stress is no longer y is equal to x, but y is equal to something into x, and that something is apparently the slope, which we have already come to see. Now let me just take that off. So this much. So now we learned how to rotate the line. But suppose I want to move the line without rotating, without changing the slope, or without rotating. I just want to move the line. What will I do? See, I have not changed the slope. I am only moving the line to right, left, top and down. So what should I do now? What should I do to the equation? For example, look at this line. This line, you already learned about y-intercept. Now suppose you don't know about that. This line crosses the y-axis. This is the y-axis. This line crosses the y-axis at this point. Okay, let me just change my pen. Okay, this line crosses the y-axis at this point, right? Now suppose I move the line up without rotating. I'm just moving the line up. What happens? This line crosses the y-axis at this point. Now suppose I move the line down, same line, without rotating. This line crosses the y-axis at this point. Suppose I move it to the right, it crosses the y-axis at this point. Sorry, it doesn't cross the y-axis here. I'm sorry, that's the x-axis. Let me just take that off. This line we cannot see where it crosses the y-axis because our screen is small. But if we extend the graph, we'll see that at some point below, let me just take my pen, at some point below it will cross the y-axis, right? And again, if I move it to the left side, again at some point above, it will cross the y-axis at some point, which we don't know because our graph is small. If we extend the graph, we will see it. Okay, so what did you see till now? You saw that there are different points of crossing y-axis when the line moves. Do you see that? So that the point where it crosses or cuts the y-axis is called y-intercept, and the point where it cuts the x-axis is called x-intercept. So if we can calculate the y-intercept, then we can, or any intercept, if we can calculate the y-intercept, we can know how the line moves. So that is why I will add a value like this, plus c, where c is the y-intercept that you have already studied. Now in the previous case, on the first case, when this was our line, we didn't need to have m and c, because slope is 1, because we saw y is equal to x 1, x is equal to 1, so slope is 1, and c, y-intercept was 0, 0, so y-intercept was 0. So you see that our c was 0 and our m was 1. So in that case, our equation of the line was y is equal to x. Now I don't know how much you have understood by what I have said, so let me just show you an example of how it really works. Now look at this. This is a normal line, okay? Anyway, it's just a line, y is equal to mx plus c. Now what happens, so what we first saw was how to rotate the line. So now the line is rotating. You see that it is just, the slope is changing. You see the slope of the line is changing. Now then we saw, without changing the slope, how to move the line. That is what we saw. So when we apply both, for example, if I change the slope and if I move, then I can put the line anywhere. See, look, the values of m are changing, the values of c are changing. So now I can place the value anywhere, place the line anywhere on the graph or on the coordinate plane, and that is why this equation is the equation of the straight line, where y is equal to mx plus c. Okay, so I don't know if the insight that I gave was a little too much, but I think I will stop it here. So in the next video we will continue to go on with the things of this chapter.